In this video, I'd like to talk about a new large-scale machine learning setting called the online learning setting. The online learning setting allows us to model problems where we have a continuous flood or a continuous stream of data coming in, and we would like an algorithm to learn from that. Today, many of the largest websites or many of the largest website companies use different versions of online learning algorithms to learn from the flood of users that keep on coming back to the website. Specifically, if you have a continuous stream of data generated by a continuous stream of users coming to your website, what you can do is sometimes use an online learning algorithm to learn user preferences from the stream of data and use that to optimize some of the decisions on your website. Suppose you run a shipping service, so users come and ask you to help ship their packages from location A to location B. And suppose you run a website where users repeatedly come and they tell you where they want to send the package from and where they want to send it to, so the origin and destination. And your website offers to ship the package for some asking price. So I'll ship your package for $50, I'll ship it for $20. And based on the price that you offer to the users sometimes choose to use a shipping service. That's a positive example. And sometimes they go away and they do not choose to purchase your shipping service. So let's say that we want a learning algorithm to help us to optimize what is the asking price that we want to offer to our users. And specifically, let's say we come up with some set of features that capture properties of the users, if we know anything about the demographics. They capture the origin and destination of the package, where they want to ship the package, and what is the price that we offer to them for shipping the package. And what we want to do is learn what is the probability that they will elect to ship the package using our shipping service given these features. And again, just as a reminder, these features X also captures the price that we're asking for. And so if we could estimate the chance that they'll agree to use our service for any given price, then we can try to pick a price so that they have a pretty high probability of choosing our website, while simultaneously hopefully offering us a fair return, offering us a fair profit for shipping their package. So if we can learn this probability of y equals 1 given any price and given the other features, we can really use this to choose appropriate prices as new users come to us. So in order to model the probability of y equals 1, what we can do is use logistic regression or a neural network or some other algorithm like that. But let's start with logistic regression. Now, if you have a website that just runs continuously, here's what an online learning algorithm would do. I'm going to write repeat forever. This just means that our website is going to keep on staying up. And what happens on the website is occasionally a user will come, and for the user that comes, we'll get some XY pair, right, corresponding to a customer or to a user on the website. So the features X are the origin and destination specified by this user and the price that we happen to offer to them this time around, and Y is either 1 or 0 depending on whether or not they chose to use our shipping service. Now, once we get this XY pair, what an online learning algorithm does is then update the parameters data using just this example X comma Y. And in particular, we will update my parameters theta as theta j gets updated as theta j minus the learning rate alpha times my usual gradient descent rule for logistic regression. So we do this for j equals 0 up to n, and that's my closed curly brace. So for other learning algorithms, instead of writing xy, right, I was writing things like xi comma yi. But in this online learning setting, we're actually discarding the notion of there being a fixed training set. Instead, we have an algorithm, and what happens is we get an example, and then we learn using that example like so, and then we throw that example away. We discard that example and we never use it again. And so that's why we just look at one example at a time and we learn from that example and we discard it, which is why we're also doing away with this notion of there being this sort of fixed training set indexed by I. And if you really run a major website where you really have a continuous stream of users coming, then this sort of online learning algorithm is actually a pretty reasonable algorithm. Because if data is essentially free, if you have so much data, that data is essentially unlimited, then there's really maybe no need to look at a training example more than once. Of course, if you had only a small number of users, then rather than using an online learning algorithm like this, you might be better off saving away all your data in a fixed training set and then running some algorithm over that training set. But if you really have a continuous stream of data, then an online learning algorithm can be very effective. I should mention also that one interesting effect of this sort of online learning algorithm is that it can adapt to changing user preferences. And in particular, if over time, because of changes in the economy, maybe users start to become more price sensitive and willing to pay, less willing to pay high prices, or become less price sensitive and they're willing to pay higher prices, or if different things become more important to users, if you start to have new types of users coming to your website, this sort of online learning algorithm can also adapt to changing user preferences and kind of keep track of what your changing population of users may be willing to pay for. And it does that because if your pool of users changes, then these updates to your parameters data will just slowly adapt your parameters to whatever your latest pool of users looks like. Here's another example of a sort of application to which you might apply online learning. This is an application in product search in which we want to apply a learning algorithm to learn to give good search listings to a user. Let's say you run an online store that sells phones, that sells mobile phones or sells cell phones, and you have a user interface where a user can come to your website and type in the query like your Android phone 1080p camera. So 1080p is a type of a specification for a video camera that you might have in a phone, in a cell phone or mobile phone. Suppose we have 100 phones in our store, and because of the way our website is laid out, when a user types in the query for the search query, we would like to find a choice of 10 different phones to show or to offer to the user. What we'd like to do is have a learning algorithm help us to figure out what are the 10 phones out of the 100 we should return to a user in response to a user search query like the one here. Here's how we can go about the problem. For each phone, and given a specific user query, we can construct a feature vector X. So the feature vector X might capture different properties of the phone. It might capture things like how similar the user search query is to the phone. So we capture things like how many words in the user search query match the name of the phone, how many words in the user search query match the description of the phone, and so on. So the features X capture properties of the phone, and it captures things about how similar or how well the phone matches the user query along different dimensions. What we'd like to do is estimate the probability that a user will click on the link for a specific phone, because we want to show the user phones that they're likely to want to buy. We want to show the user phones that they have a high probability of clicking on in the web browser. So I'm going to define y equals 1 if a user clicks on a link for a phone, and y equals 0 otherwise. And what I would like to do is learn the probability that a user will click on a specific phone given the features X, which capture properties of the phone, and how well the query matches the phone. To give this problem a name in the language of people that run websites like this, the problem of learning this is actually called the problem of learning the predicted click-through rate, or predicted CTR. It just means learning the probability that the user will click on the specific link that you offer them. So CTR is an abbreviation for click-through rate. And if you can estimate the predicted click-through rate for any particular phone, what we can do is use this to show the user the 10 phones that they're most likely to click on. Because out of the 100 phones, we can compute this for each of the 100 phones and just select the 10 phones that the user is most likely to click on. And this would be a pretty reasonable way to decide what 10 results to show to the user. Just be clear, right? Suppose that every time a user does a search, we return 10 results. What that will do is it will actually give us 10 XY pairs. So this actually gives us 10 training examples every time a user comes to our website, because for the 10 phones that we chose to show the user, for each of those 10 phones we get a feature vector X, and for each of those 10 phones we show the user, we will also get a value for Y. We will also observe a value of Y depending on whether or not they clicked on that URL or not. And so one way to run a website like this would be to continuously show the user, your 10 best guesses for what are the phones they might like. And so each time a user comes, you would get 10 examples, 10 XY pairs, and then use an online learning algorithm to update the parameters using essentially 10 steps of gradient descent on these 10 examples. And then you can throw the data away. And if you really have a continuous stream of users coming to your website, this would be a pretty reasonable way to learn parameters for your algorithm so as to show the 10 phones to your users that are maybe most promising and that they're most likely to click on. So this is a product search problem. We're learning to rank phones, learning to search for phones example. So I'll quickly mention a few others. One is if you have a website, you're trying to decide what special offers to show the user. This is very similar to phones. Or if you have a website and you show different users different news articles. So if you're a news aggregator website, then you can again use a similar system to show to the user, what are the news articles that they are most likely to be interested in, and what are the news articles that they're most likely to click on. Closely related to special offers would be product recommendations. And in fact, if you have a collaborative filtering system, you can even imagine a collaborative filtering system giving you additional features to feed into a logistic regression classifier to try to predict the click-through rate for different products that you might recommend to a user. Of course, I should say that any of these problems could also have been formulated as a standard machine learning problem where you have a fixed training set. Maybe you can run your website for a few days and then save away a training set, a fixed training set, and run a learning algorithm on that. But these are the actual sorts of problems where you do see large companies get so much data that there's really maybe no need to save away a fixed training set, but instead you can use an online learning algorithm to just learn continuously from the data that users are generating on your website. So that was the online learning setting, and as we saw, the algorithm that we applied to it is really very similar to the stochastic gradient descent algorithm, only instead of scanning through a fixed training set, we're instead getting one example from the users, learning from that example, then discarding it and moving on. And if you have a continuous stream of data for some application, this sort of algorithm may be well worth considering for your application. And of course, one other advantage of online learning is also that if you have a changing pool of users, or if the things you're trying to predict are slowly changing, like if your user taste is slowly changing, the online learning algorithm can slowly adapt your learned hypothesis to whatever the latest sets of user behaviors are like as well.